Hi, I'm Lakyn, and this is the Sweet Density Lab. And today we're going to be seeing if cutting a candy bar will affect the density of the candy bar. So first, we're going to start out by measuring the length of a Milky Way, and then measuring the length of a Snickers bar. So the length for the Milky Way bar is 8.75 centimeters, and the length for the Snickers bar is 9.5 centimeters. The width for the Milky Way is 2.75, and the width for the Snickers is 2.5. The height of each one of the bars is 1.5 centimeters. So calculating the volume of each bar, the Milky Way's volume is 34 cubic centimeters, and the volume for the Snickers bar is 36 cubic centimeters. Next, we're going to take the mass of both of the bars. So the mass of the Milky Way bar is 52.2 grams, and the mass of the Snickers bar is 52.7 grams. Okay, so next we're going to get the density. So to get the density, you're going to divide the mass divided by the volume. So 52.2 divided by 34 is going to mean that our density for the Milky Way bar is 1.54 grams per centimeters cubed. And then for the Snickers bar, we'll do 52.2 divided by 36, which gives us 1.45 grams per centimeters cubed. Now on to the fun part. We're going to cut both of the bars in half to see if that's going to affect the density at all. Cut. Okay, next we're going to measure the length of each one of the bars, because since we only cut them in half, the width and the height are going to still stay the same. So the length of the first half of the Milky Way bar is 4.25 centimeters, with the second half being 4.5 centimeters. And then on the Snickers bar, the length is 4.5 centimeters on the first side and 5 centimeters on the second side. So taking the volume into account for each one of the sections of the bar, the volume for the first section is 17.5 centimeters cubed, and the volume for the second side of the Milky Way bar is 18.5 centimeters cubed. So next we're going to take the mass of each side of the bar. The first half of the bar is 25.9 grams, and the second half of the bar is 26.5 grams. So to calculate the density for both parts of the Milky Way bar, we're going to do the mass divided by the volume again. So we'll calculate 25.9 divided by 17.5, which is going to give us 1.48 grams per centimeter cubed for the first half of the bar. We'll do the same thing with our numbers for the second half, which is going to give us 1.43 grams per centimeters cubed, meaning that if we calculate the average density, it is 1.45 grams per centimeters cubed, which is, compared to the whole bar, only a couple tenths of a gram off. So as of right now, we can assume that cutting the bar does not affect the density, but we'll go ahead and do the Snickers bar as well. So the volume for the first half of the Snickers bar, taking into account all of our measurements, is going to be 16.9 centimeters cubed. And then for the second half, taking all of our measurements into account, it is 18.75 centimeters cubed. We're going to weigh both sides. The first side comes in at 24.8 grams, and the second side comes in at 27.2 grams. So, doing our density equations again, the first half of the bar comes to 1.46 grams per centimeters cubed, and the second comes in at 1.45 grams per centimeters cubed, meaning that our average here is going to be 1.455 grams per centimeters cubed for the average density, which is almost identical to the density that we started with before we cut the bar. So based on our calculations that we have come up with for this lab, we can conclude that our hypothesis was accurate as of now, because cutting the candy bars in half does not affect the density.